Hey everyone, welcome back to the channel. Today we're diving into one of the most famous equations in history, E equals mc². We all know it. We've all seen it on t-shirts. But do we really understand its profound impact? It's more than just a cool-looking formula. It's the key that unlocked the atom and paved the way for nuclear power. And it all started with one man, Albert Einstein. Now, let's get one thing straight right from the start. Einstein didn't invent the atomic bomb, nor did he directly work on the Manhattan Project. His role was much more foundational and, frankly, much more mind-bending. Back in 1905, a year he later called his miracle year, Einstein published a series of papers that completely changed our understanding of the universe. Tucked away in one of these was a tiny, elegant equation, E mc². So what does it actually mean? E stands for energy, m for mass, and c is the speed of light. The equation tells us that mass and energy are two sides of the same coin. They are interchangeable. You can convert a tiny amount of mass into a colossal amount of energy. Why? Because c, the speed of light, is a gigantic number, about 300,000 kilometers per second. And in the equation, you square it. So, c² is an almost unimaginably huge number. This means that even a minuscule speck of matter, if converted completely, would release a staggering amount of energy. For decades, this idea was purely theoretical. It was a beautiful piece of physics, but a bit like a recipe for a cake you couldn't bake. Scientists knew this incredible energy was locked away inside atoms, but they had no idea how to get it out. Einstein himself was skeptical that it would ever be practically harnessed. He once said that splitting the atom would be like shooting birds in the dark in a country with very few birds. The story takes a dramatic turn in the 1930s. The world was on edge, and scientific discoveries were accelerating. In 1938, a team of German chemists, Otto Hahn and Fritz Strassmann, along with their colleague Lise Meitner, were experimenting with uranium. They were bombarding uranium atoms with neutrons, expecting to create heavier elements, but they found something bizarre, something that defied the known laws of chemistry at the time. They found barium, an element that's much, much lighter than uranium. It was like throwing a baseball at a window and finding a soccer ball on the other side. They were baffled. Hahn wrote to Meitner, who had been forced to flee Germany. Puzzling over the results with her nephew, Otto Frisch, Meitner had a flash of insight. She realized what was happening. The uranium nucleus wasn't just chipping a piece off, it was splitting in two. And when they did the math, they found that the two smaller nuclei, plus the neutrons that were released, had slightly less mass than the original uranium nucleus. Where did that missing mass go? This is where Einstein's E or mc² comes crashing back into the story. Meitner and Frisch realized the missing mass hadn't just vanished. It had been converted directly into energy, exactly as Einstein's equation predicted. They calculated the amount of energy released from a single split atom, and the number was enormous. They had discovered nuclear fission. This discovery spread like wildfire through the physics community. Suddenly, Einstein's theoretical birds in the dark were everywhere, and scientists knew how to find them. The key was a chain reaction. When one uranium atom splits, it releases energy, but it also releases a few extra neutrons. If those neutrons go on to hit other uranium atoms, causing them to split, you get a self-sustaining chain reaction. One split leads to two, two to four, four to eight, and so on, releasing an avalanche of energy in a fraction of a second. This is where the history gets a bit darker. With the outbreak of World War II, scientists, many of whom were refugees from fascism, became terrified that Germany might develop an atomic weapon. This fear prompted the famous letter to President Franklin D. Roosevelt. Urged by his colleagues, Albert Einstein, the world's most famous scientist and a dedicated pacifist, signed a letter warning the US government of this possibility and recommending they start their own research program. This letter was instrumental in the creation of the Manhattan Project. It's one of history's great ironies. The man who dedicated his life to peace and understanding played an indirect but crucial role in the birth of the most destructive weapon ever created. Einstein later expressed deep regret over signing the letter, calling it the one great mistake of his life. He had hoped the bomb would be a deterrent, not something to be used. But the story of E or mc² doesn't end there. After the war, scientists began to explore the peaceful applications of this incredible power source. The same principle of nuclear fission, the same chain reaction that powers a bomb, could be controlled. Instead of an explosive runaway reaction, you could have a slow, steady, controlled release of energy. This is the core concept behind a nuclear power plant. Inside a reactor, rods of uranium undergo a controlled fission chain reaction. This reaction generates an immense amount of heat. That heat is used to boil water, creating high-pressure steam. The steam then turns a turbine, which is connected to a generator that produces electricity. It's essentially a very, very sophisticated steam engine powered by the conversion of mass into energy. Think about the scale of this. A single uranium fuel pellet, about the size of a gummy bear, can produce as much energy as a ton of coal. It's a testament to the sheer power locked away in the atomic nucleus, a power first quantified by E or mc². This technology now provides a significant portion of the world's electricity, offering a source of power that doesn't produce greenhouse gases. Of course, nuclear power has its own set of challenges, from managing radioactive waste to ensuring the safety of the reactors. These are serious engineering and ethical problems that societies are still grappling with. The legacy of Einstein's equation is complex and double-edged. It gave us a new understanding of the cosmos, but it also gave humanity a power that requires immense responsibility. So, from a thought experiment in 1905 to the power plants that light up our cities today, the journey of E or mc² is a story of human ingenuity, discovery, and the profound consequences that come with unlocking the secrets of the universe. It shows how a single, simple idea can ripple through history, changing the world in ways its creator could never have imagined. Einstein gave us the map, but it was up to us to navigate the territory, and we are still navigating it today. Thanks so much for watching. What are your thoughts on the legacy of E or mc²? Let me know in the comments below. If you enjoyed this journey into the heart of the atom, please give this video a thumbs up and consider subscribing for more stories from the world of science. We'll see you in the next one.